All right, everyone, welcome to another physics video lecture. Today, we're going to be doing a review, okay? As I'm going through this, I want you to follow along with your own PowerPoint, and I want you to take your own notes, okay? So grab a piece of paper, write all this down, and this is going to be what you can use to take your quiz today, okay? All right, so let's get into it. Everything you need to know. All right, relationships. There's two types of relationships. Direct relationships, okay, and inverse relationships. A direct relationship, as one variable gets bigger, it causes another variable to get bigger. And vice versa. If the variable gets smaller, the other variable gets smaller. In class, we saw this when we did our height versus foot lab. Remember, as your height increases, your shoe size increases, usually, and as your height decreases, your shoe size decreases, right? This is always going to be a positive slope on a graph. It's always going to go up, right? An inverse relationship is one variable increases, it causes the other variable to decrease, and vice versa, okay? This would be like when we talked about cars. Usually the bigger, the heavier a car is, the slower its acceleration. And vice versa, smaller cars have higher accelerations. Okay, think about, a Ferrari versus an 18-wheeler. This is always going to be a negative slope. It's always going to point down. All right. Next, distance and displacement. Distance is how far an object has traveled. Okay, it is what is called a scalar unit, meaning that it has no direction. Okay. And all that means mathematically is that it's never negative. It's always going to be a positive number. So if I walk 5 feet forward and 5 feet backwards, all right, I don't care about forwards and backwards. All I do is just add up the distances. 5 plus 5 is 10. All right, that's my distance. Displacement is how far an object is from where it started. It is what is called a vector because it has direction. Now we care about which way you're going, and now one way is positive and the other is negative. So now if I walk 5 feet forward and 5 feet backwards, okay, forward is positive, backwards is negative. So now I have 5 minus 5, which is 0, because look, I'm right back where I started. Okay, my displacement is 0. To solve this, always draw a diagram. All right, always draw a diagram. Let's look at an example. Okay, here we have a child running. So let's look. The child is going to go 10 meters south. All right, so here we go. We're going to go down 10 meters. Boom, 10 meters. We're then going to go 15 meters west. 15 meters. Again, this isn't perfectly to scale. And then we go another 10 meters south. Okay. Up first, what is my distance? Remember, distance is scalar. Distance does not care about which way we're going. I don't care about north, south, east, west. All I do is add these things up. My first distance was 10. My second is 15. And my last one is 10. 10 plus 15 plus 10 equals 35 meters. That's easy. Doesn't matter what direction you're going, you just add them up. Displacement, on the other hand, does care about direction. So what we're going to do whenever we have displacement, we put a dot where we started, we put a dot where we finished, and we straight line connect the dots. Okay? Now, as you see, this is kind of a weird line to find, so what we have to do is make a triangle, specifically a right triangle, okay? Now, if you're just going up and down or back and forth, you don't have to make a triangle because you're not turning left and right. But whenever there's turns, you gotta make a triangle. Take your 2 dots, and what you do is you draw 2 lines that connect, boop, as a right triangle. You can go that way, or you can go that way. I'm gonna go this way. Boom. Boom. Now the sides of this triangle, this side of the triangle is the same as this length right here. So I know this side is 15 meters, Whereas this side of the triangle is going to be equal to this distance, 10, plus this distance, 10. 10 plus 10 gives me this side is 20 meters. And then this big side here that I'm trying to find, we always call this side C. It is the hypotenuse. It's the hypotenuse because it is the longest side and it does not touch the right angle. These two sides, we call these A and B, whichever. This one could be A, this could be B, this could be A, this could be B. We'll call this one A, we'll call this one B. They make the right angle. All right, so to solve this, we need to use our Pythagorean theorem. What is that? The Pythagorean theorem says A squared plus B squared equals C squared. All right, fill in our numbers. A is 20 plus B squared is 15, and that equals C squared. Grab your calculator. Again, you can use Google. There's a calculator on your phone. There's a a million calculator apps that are all free. Plug this in. 20 times 20 is equal to 400. 15 times 15, or 15 squared, is 225. That equals C squared. Always bring it down. 400 plus 225 equals 625 equals C squared. And now this is not my answer. Remember, this is C squared. So we have to do the opposite of squaring, which is taking the square root. Plug that into your calculator, and you will get C is equal to 25 meters. Always with the unit. Always put your unit down. Again, copy this, work through it, write this down, pause the video. All right. The next thing we have to talk about are graphs. So far, the only graphs that we care about are position versus time graphs, okay? Or we call them distance versus time graphs, or displacement versus time graphs, right? Time always goes on the x-axis, which is the horizontal, the flat axis. That's because it is always the independent variable. Always. You, me, nobody can control time as of yet. It's always moving forward. It's independent. We measure time in seconds. Now, position, distance, displacement. On a graph, you'll see all three of these names. Usually position or distance, sometimes displacement. But you'll see any of these three names, and they always go on the y-axis, the vertical axis. That's because they are dependent, okay? They're dependent on what time you're looking at. Where you are depends on what time it is, okay? Kind of weird to think about, but true. We always measure it in meters or centimeters or kilometers, but some version of meters, okay? And the slope of this graph is your velocity, okay? I'll show you why in a second. That's because it's measuring meters per second. Meters divided by seconds, or what you'll see is m divided by s, which I'll say is meters per second, but that means meters divided by seconds. Good? Now, I talked about slope. Slope is super important. We had a whole lesson on slopes. Slope equals the rise over the run of a line. The rise of the line, rise is y, right? The y goes to the sky, and the run is the horizontal. Run is x. And the way you find change is always 2 minus 1. Rise over run, 2 minus 1. Where you finished minus where you started. So y2 minus y1 divided by x2 minus x1. This is the rate of change, okay? It's how much one variable affects the other. And what this means is the steeper the slope, okay, the more change you have. Meaning here, the steeper the slope, the faster you're moving. So this would be really slow, faster, 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 slower, 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 slower. Stop. That's 0. Slower, slower, faster, 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 faster. Okay? This is super fast, super positive slope. This is super fast, super negative slope. All right? And the only difference is, again, direction. This would be moving forward. This would be moving backwards. All right, so let's look at an example. All right, here we have 4 lines. Okay, I'm just going to go ahead and label them. We're going to call these A, B, C, and D. And I want to know the velocity of each one of these lines. All right, so for A, what we're going to do is we are going to pick 2 points. I'm going to pick, this is my point number 1. This is my point number 2. Okay, so for A, we're going to make a graph. Okay, I have an X value and a Y value. First point, second point. My first point, my X and my Y are, go. X is 0, Y is 0. Boom, boom. My second point, all right, come over here, sorry. My X is 3, and my Y is 6. So X is 3, Y is 6. Okay, and again, we remember it is Y2 minus Y1 divided by X2 minus X1. Okay, I'm going to go ahead and plug my numbers in, okay, right over here. Can I fit them over here? I can fit them over here. All right, Y2 is 6 minus Y1 is 0 divided by X2 is 3 minus X1, which is 0. 6 minus 0 is 6 divided by 3 minus 0 is 3. And 6 divided by 3 is, I'm squeezing it in, 2. Okay? Specifically, I'm going to move this. I didn't give myself a lot of room. Sorry. So I'm going to take this and actually bring it over here. So this would actually give me 6 divided by 3, which is going to be equal to 2 meters per second. Why meters per second? Well, look at it. We have y on top, and our y-axis is meters. So this up here is meters, divided by our x-axis, which is seconds. Meters divided by seconds, or we call it meters per second. All right? Now line B, I don't need to calculate. Why not? Well, because it's flat. And I know that all flat lines have a slope of 0. So if the slope is 0, I know the velocity is 0. Remember, velocity is speed, okay? It's just speed that's positive or negative, right? So here, if my position doesn't change, if I'm standing still, I'm not moving forwards, I'm not moving backwards, my speed is 0, my velocity is 0, okay? Now we see C. We see C is right here, okay? We got a positive number for A because we're going forwards, right? We're moving up in our position, okay? That means we have a positive velocity. Now my line is going down, which means we're gonna have a negative slope, which means we're gonna have a negative velocity. Well, let's calculate. I'm gonna use this point and this point right here. Now, just to show you how to do this correctly, we'll make a chart. So again, we have our X and Y, 1 and 2, okay? My first position's right here. My X value is 5. My Y value is 6. And my second point, and it's the second point because it's on the left, right? First point, or sorry, it's on the right. First point's on the left. Second point's on the right. My X value is 8. And my Y value is all the way over here, 3. Okay? Same equation, okay? So I'm going to plug my numbers in. Y2 is 3. Minus Y1 is 6. Divided by X2 is 8. Minus X1, which is 5. Again, I didn't write it down. I usually like to, but it's right there, just saving space. Okay? 3 minus 6 gives me negative 3, divided by 8 minus 5, which is positive 3. Negative 3 divided by positive 3 gives me negative 1 meters per second. Beautiful. And again, it's meters, Y, divided by X, which is seconds. And obviously our last line here is 0 meters per second because they're flat. There is no change in position. I'm not moving forwards or backwards. Okay? Now, you can also look at these two numbers I got here. Look at this first one. I got positive 6 divided by 3. Well, look at the graph. Okay? Here, I'm saying that my rise, my change in y, right? Rise over run goes positive 6. 1, 2, 3, 4, 5. I go up 6, and my run is 3. 1, 2, 3. 6 divided by 3. Rise over run. Similarly, here, I got negative 3 divided by 3. Well, look at this. My rise goes 1, 2, 3, down, negative, negative 3. My run, 1, 2, 3, is positive 3. I'm moving forwards 3. Negative 3 divided by 3 equals negative 1. All right, last question, distance and displacement. With a graph, these are easy. Okay, your distance is how far you travel. So look at each line. This first line, I went from 6 or 0 to 6. Okay, that means my distance was 6 plus how far did I go in this line? Well, I didn't go up or down, so my distance is 0. I stayed still. Here, I went down from 6 to 3. 6 to 3 is negative 3, but it's distance, so I don't care about negatives. And then my last line is 0. So my distance is 6 plus 3, which is 9 meters. I moved 9 meters total. I moved 6 meters here. I moved 3 meters here. Again, don't care about negatives. My displacement's how far I am from where I started. Well, that's easy. Look at the y-axis. This is your position. I started at 0, and here I ended right here, which you can't see is 3. I started at 0, I ended at 3. I went up positive 3 meters from where I stopped. Okay? All right. Last but not least is I'm going to show you one more graph. Again, take a second. Draw the graph, write these down. If you work through these problems yourself, okay, if you take these notes, you will crush this quiz, I promise. Okay. All right, last but not least, I got one more graph. This graph has 2 different lines, all right? This is still a position versus time graph. We measure time in seconds. Here we're measuring position in centimeters. That's fine, okay? That's just take a meter, divide it into 100 little pieces, and that's a centimeter. 1 inch is about 2.5 centimeters, just to give you an idea. Centimeters about yay big. Okay, so here's a race between A and B. Again, every graph tells a story, okay? So we have A and B. This is our race. Let's answer some questions about the race. Number 1, who had a head start? And you're like, Mr. Norris, read the graph. So let's look. Let's look at A. Where did A start? A started at 0 centimeters, whereas B started at 20 centimeters. So who had a head start? Well, it's B. B started 20 meters ahead of A, right? It's a story. Number 2, who won the race? Well, we have to go to the end of our time. This is where we began the race, right? Ready? The race goes 1 second, 2 seconds, 3 seconds, 4 seconds, and then the race ends at 10 seconds. Who's farther? Well, let's look. B is here at 50 centimeters, where A is all the way up here at 85. You can see that A won the race. A is farther, right? A's distance is greater. A won. So this question is who ran faster, okay? All you have to do to see who's faster is to see which slope is steeper. Look at the 2 slopes. Which one's steeper? Which one would be a harder hill to climb up? And obviously, the steeper slope is A, right? B is a nice, easy slope. A is super steep. If you're ever asked a question about slopes and who's running faster, if they just say faster, we don't care if it's positive or negative. So if you had these lines, okay, this one would be faster. Okay, this is faster because the slope is steeper. All right, this is a shallower slope. And last question, when were they at the same place? Well, that means when is their position the same? And their position is the same right there, which is right at about 30 centimeters. But I said when. When means a time. And they were at the same place at 4 seconds. Cool? All right, guys, this is your review. This is everything that you need to know. Watch the video as many times as you need to. And again, I can't stress this enough. Write down your own notes, okay? This is a beautiful review of everything that you need. Hold on to this paper. You will be using it all semester. All right, guys? Be well, be good. I'll see you in class.